So roughly 2 weeks ago, Anthropic announced that they would be open sourcing their Model Context Protocol. And given its potential, I thought that it didn't quite get the attention it deserved. The word protocol is a little intimidating and led to quite a bit of misunderstanding in the community as to what this really is and how you can use it to build an AI agent using any LLM of your choosing. So today, let's take a quick look at the specification. And afterwards, I will walk you through an example of how you can build your own AI agent with any LLM model that leverages MCP. If you are already familiar with the protocol and you just want to get to the part of the implementation, there are timecodes below, and the repository is also linked below, which can serve as a baseline for your own implementations. So what is the Model Context Protocol? Basically, the graphic down here explains it all. So the Model Context Protocol defines how your host or client and a server communicate. It's really just a format for the request and the response, outlining how the communication takes place, how the data is validated, and the shape of the data in general. Now, there are really two parts to this specification. On the one hand, you have the server. The server essentially just receives requests from your client, processes them, and returns a result. These requests can usually be list requests, stating what sort of capabilities the server provides. And they can be calls, execution requests, either to provide access to a resource or to execute some sort of command or function. The client, on the other hand, is the one that is in charge of actually calling the server, either to request a list of the capabilities the server provides, so that can be fed into the LLM, or when an LLM returns that it wants to perform a function call, it actually is the glue between the function the output of your LLM, and then actually executing it on the server, waiting on the response, and feeding that back into your LLM. Now, you will probably hear host and client being used interchangeably, and their wording is a bit unique here. The host is essentially the entire application that is executing your LLM and potentially has multiple clients. Because the way they designed the system is that there's only a one-to-one connection between a client and a server. So, for example, if you're designing an application where you want to provide your LLM access to a data source, another data source, and potentially executing some other functions completely unrelated, in that case, you would have multiple clients that would be listing their server capabilities or requesting the server capabilities and providing those to the LLM, so the LLM is aware of those functions. Something to note is that with the current implementation, the servers have to run on the same environment where your host is being executed, because your host basically starts the servers up on startup. Now, that sounds like a very big limitation, but it really isn't, because on the one hand, Anthropic already announced that they would be adding the capability for remote server handling soon. But on top of that, there's really nothing that prevents you just from creating a very thin MCP server proxy, which then just forwards the request to another remote server that essentially has the same interface and accepts those and acts on any data source. So why is MCP such a big deal? It doesn't really allow you to do anything that wasn't technically feasible before, right? Many of the big LLM providers already have the ability to execute function calls, or at least for the LLM to specify which functions it would like to call, and then simply wait on the response. It is very similar to how, for example, the SOAP interface or the REST interface allow you to provide access to your resources without having to know the implementation details of the clients consuming that, which could really lead to a huge boom in LLM capabilities that individual developers are providing to different applications and different resources, and any AI developers can simply include in their own agent design, for example. A way to potentially think about this is it is the internet explosion for AI agents and AI-enabled software. To demystify the word protocol a little bit, let's take a look at the specification. Now, most notably, the Model Context Protocol outlines 3 different major concepts for servers to implement. One is prompts, which just allows your server to return a prompt that should then be executed by the LLM. Now, these prompts could, for example, be enriched with dynamic data or be just customized to some user data that is also provided. You have resources, which simply provide access to ideally mostly static documents that would then be called and accessed when needed. And then finally, you have tools. And At the moment, I feel like tools are the most important concept of them all, because you can really wrap the other two, prompts and resources, into the tools concept as well. So let's deep dive into tools a little bit. We have the list change notifications part. Let's skip over notifications for now. It's simply a way of informing your clients that the capabilities of your server have changed and they might need to refresh the tools list that they currently have, which I don't think is super critical for now. More interesting is the listing tools request. So for tools, there are basically just two endpoints, so to say. One is tools list and one is tools call. The tools list simply receives a request that it should list all of the tools that the server provides. And then you can see the response. You can also see that these are simply JSON RPC requests. So that means there is no magic going on here. There is no proprietary protocol. There is no proprietary encoding or decoding magic happening. It is simply a server receiving this request and then returning a response. This also means that if you don't want to use their provided SDKs, but instead just sort of provide your own implementation, the limitation of running servers locally is just completely mute. That being said, the SDKs that they provide are very helpful and allow you to get a lot of the boilerplate out of the way. In this example, you can see that they provide a single capability, which is the ability to get the weather for a particular location. And you can see a JSON schema in here, which defines which fields need to be provided, along with the description of what this data should entail. Now, this is very important because this is what gets input into your LLM as a list of abilities for the LLM to perform. And if your model then identifies based on the user request and the provided capabilities that there is a function or a tool that it should call, then this will tell the LLM how it needs to call that function, which parameters to include, and the format and other things to consider. This is also super powerful because if you provide multiple tools, for example, a list and a delete and a create capability, then your LLM is able to figure out on its own if it needs to, for example, delete an item, that it might need to list the items first to get the ID, which is then used in order to delete that particular entity. Now, just to reiterate, listing tools is probably something that you would perform before your LLM gets executed in order to feed that list of capabilities into the prompt. Now, calling tools, on the other hand, is what happens after your LLM returned a function call based on the list provided. Now here you simply have a request with the method tools call and the parameters included as well. If you use the SDKs provided by Anthropic, your server will automatically parse these arguments and understand if they meet the required specifications. And then finally, you have a specification of what the result should look like. You have the result object, which defines if this is an error or not. And then you have an array of content. Usually you will have a type, which can be a text. There are also other types like resources, images, etc. And then depending on the type, another property outlining the content of that result. As a best practice, if an error occurred, the text is probably also a good place to put the error message so that your LLM is able to convey that to the user as well. Now that is already all you need to know about the Model Context Protocol specification. You can look into resources and prompts as well to identify how they are used, but personally I find the tools to be the most powerful one given the current state of LLMs, and also very simple to sort of implement any other type of functionality into it. What I feel Anthropic documentation is doing really well is outlining examples, especially for designing servers. So they have a wide list of example servers provided here. And they also go into examples of how to implement tools, for example, both in TypeScript and in Python. So just quickly glancing over the TypeScript example for an MCP server, you define a server object, list the capabilities that it provides. So if you have some tools to provide, you provide an empty tools object here, which is a little counterintuitive. You would sort of imagine that you already put your tools right here. And then you always have this pattern of the server setting a request handler. And then inside that request handler, you specify the type of schema that this handler implements. This is to perform sort of request and response validation. So here you define the list tools request schema. And you simply, in this case, return a static list of tools where you have the calculate sum, a description of what this is supposed to achieve, and then outlining the schema and what it performs. You will notice here that A and B don't have additional descriptions on their properties, which of course you could include for more detail. But given the nature of the name of the tool, its description that it's adding two numbers together, and given the fact that A and B are also specified as type number, there's probably not much value in adding additional description to those two properties, but you could. And then finally, you simply have the actual implementation of adding the ability to handle tool calls. For that, you simply have one general request handler that accepts that tool call. And then inside the request handler, you figure out which tool was actually called. Now you can already see that this will probably turn into quite a lot of spaghetti code if you keep it as simple as in this example. So I highly recommend writing some minor abstractions where you can just define those request handlers individually, and then you would have one handler that takes care of identifying the parameter and then calling the correct function internally. Now that's already all there is to servers. You can already see how potentially easy it is to simply create a server that acts as a very thin wrapper around any API that you've already designed for any tool, or even any third-party API. You would simply be receiving the request, transforming it, for example, into an Axios request, contacting the server resource, and then transforming it back again into the response type required. Most of the work is simply getting that API specification of whatever you want to call, and then transferring that into the list tools schema, which isn't that much effort and can probably be done with the help of an LLM anyway. Now, clients or hosts, on the other hand, are a little more interesting, I feel like, because that's where you actually get to make use of those server resources. Depending on who you are, if you're a developer of a standard application and you want to provide LLM access to your application, then of course servers are more interesting. But if you're into building AI agents, then you're probably building clients. And in my case, I want to build my own Gen AI workflows. I don't want to rely on the list of already working clients they provide here because of the limitations that they provide. And maybe because I want to use LLMs of other providers as well, for example, the OpenAI series. Now, when it comes to clients, I feel like the documentation is lacking a little bit because they're simply referring to their TypeScript SDK documentation or Python. And if you go there, they will only tell you how you can spin up a client and performing some requests, even though there are already better requests available in their SDK, and also because there is really no implication of how to use it with your LLM model. So to help with that a little bit, I set up a test repository, linked to that in the description below, that implements the MCP client using any server of your choosing, and then utilizes the OpenAI model to actually interact with your MCP server. In order to run the project, you need to have Dino installed, and you can simply run dino run dev after you set up your environment variables. And it implements a very simple CLI and chat interface. In my case, it is set up to an MCP server I built that interacts with my freelancing management tool that I built a while ago. So here I will ask it to create a new freelancing project. And what it does is it has access to my MCP server, which provides the capability to list projects, to add projects, to delete projects, and also to log this user in. So you can see here the assistant is trying to add the project. It notices that it isn't logged in, so it attempts to log in. It verifies the login by listing the projects, and then it adds the project once again. Finally, it provides a confirmation that it has added that successfully. In the example env that I provide, this isn't set up, but instead you have the local file server set up, so you can chat with your file system when you define the path that your LLM has access to. Now let's take a look at the repository to see how our client makes use of our MCP server and how we connect it to the OpenAI specification. But before we do that, if you have made it this far and you enjoyed the video, please consider liking and subscribing. It really helps out the channel. Here I have the project opened, and this is currently the env.example. So first of all, you will want to copy that into a regular .env file. Ensure that you change the OpenAPI key. and then define any server that of your choosing. This can either be one of your own, or it can be a server provided in their public GitHub repository. Also, I would highly recommend setting debug to false, otherwise you will get a lot of messages in between. I've set up some helper files like messages and CLI, which simply help with how to parse user input and display the messages. But most importantly is the main.ts file. In here, you will see that we have two main functions, the main and the agent loop function. The main is what gets executed right away. Inside this main function, what we do is we create a new message handler, which simply allows us to append messages and then also print those messages to the CLI. We define our OpenAI instance. And then this is the first part where we interact with our MCP server. And this is just listing the tools. So this makes use of the MCP client, which is defined in the client.ts file. This is really just a one-to-one copy from the documentation. And the MCP client here is a helpful abstraction that already has the capabilities to call tools, to list tools, and implements the schemas correctly. So going back, we can see that we perform the list tools here. Now, this list tools is very specific to the one server that we have connected this MCP client to. If you have multiple servers you want to connect to, you would also need multiple clients. So you would need to repeat this step for every client that you have. Now, while the MCP specification of the tools list is already very close to what you can input into an OpenAI model, it's not identical. So for that, there is this map tool list to OpenAI tools helper, which is in the OpenAI utils file. You have the two schemas here. This one is what OpenAI is able to understand, and this is the one that the server returns. You can already see the similarity in name, description, and parameters. And you basically have to wrap this inside this function, type function object. So this is simply what this mapper does down here. So going back to our main.ts file, once we have the correct format of the OpenAI tools, we have a little try-catch statement down here that ensures that if there's any error occurring in the entire process, we log the error, we save the messages locally for debugging purposes into a messages.json file, and then we close the MCP connection, which allows the entire program to shut off. Inside the try statement, we have what is effectively an infinite loop, where we start out asking for user input. And if the input is word for word exit, then we also simply store the messages and break out of the infinite loop. Or if it's any other message, we add it to our message handler and initiate our agent loop, which we defined on top. The agent loop itself is also simply a loop that uses our OpenAI instance and prompts OpenAI for as long as until the user request is completed. So going back up, let's take a look at the agent loop. There is really nothing magical happening here either. We simply iterate for a maximum number of autonomous steps just for safety reasons. And this is where we make use of the tools that we passed into it. So we have our OpenAI chat completions API. We provided the model that we use, the temperature and the messages. Nothing new here. But then we have the tools. Now, if you've worked with the OpenAI function calls before, this is familiar to you. The only difference is now this is not something that we define in our code base, but something that we requested from a server running externally. So then we await the response. And once we have the response, we add it to the messages. Inside, we have a little isDone check, which really simply checks if there is a finish reason called stop on the response, which tells us that the agent is done processing the request and we can go back to asking the user for input. If it is not done, we apply tool calls if present. And this is where the second part of the MCP implementation comes into play. So in here, we check if the response has a tool calls property on it. Now, this is not MCP specific. This is OpenAI specific. So OpenAI announces that it wants to perform function calls inside this list. If there are no tool calls included, we simply return early with an empty array of new messages. However, if we do have function calls, in that case, we iterate over each of them. And we note down the ID because the OpenAI interface requires us to add the tool ID of the executed function call into the subsequent messages. And then we extract the name and the arguments, which OpenAI also provides to us. Then we simply call tool, which is a very thin wrapper around the MCP client we defined earlier. It also has a call tool method, but the only difference is that we do our input argument parsing and we wrap this in a try catch in a way that it doesn't throw in the end, but if it throws, we return an error object instead. If we go back to our OpenAI utils, we can see that if we have an error return, we simply append a new message detailing the details of the error and adding the tool call ID. If there was no response at all, for whatever reason, we also inform the LLM about it. So for example, if you get a 401 unauthorized error, then your LLM can look at the tools it has available and identify if it might be able to act on it without having to return to the user that it's not able to follow through with their command. Or if some of the parameters might require a different format, then the LLM can also experiment potentially with different formats of calling that function. And then finally down here, this is where it becomes MCP specific again. The MCP server can return different types of content. In this case, I've only implemented the text type of content, which will then add the result as well. Any other type will currently throw an error and just exit out of the program entirely, because then that's something you should probably implement. When you're deploying this to actual users, I would highly recommend not throwing here, but instead using the pattern used above. Finally, we simply return all of the tool call results, which is simply a list of messages that we defined earlier. So going back to our main function, that's already it. We check if there were any tool call responses. If so, we add the messages to our message handler. And then finally, we add another prompt, which is a system prompt that it should perform any required next steps. I'm not sure this is strictly necessary, but I found that it helps in some cases. The prompts are defined in the prompts TS file, which might be interesting to look into. This is also how, in the example I showed you earlier, the LLM was actually aware of the correct dates to set the project accordingly. So that's already it. You have the main loop, which takes care of ensuring that the user is prompted for input when the LLM is done. And you have the agent loop, which tries to perform as many steps as possible up to an upper limit of, in this case, 10, for the agent to solve the user's request. And at the end, the user gets prompted for input again. If this is a baseline you want to use to play around or build your own projects on top of, then the repository link is in the description below. It's all open source, so do with it as you please. What this project really outlined to me is how incredibly simple and fast it is to set up your own MCP server to provide virtually any capability that you desire to an LLM, and how simple it is to hook up the protocol and the client to any third-party LLM of your choosing. I feel Anthropic did a really good job here at looking at the industry practices and the specifications that are already implemented and align their protocol as closely as possible to it. That being said, I think this is a great step into a future where LLMs, especially LLM agents, are able to access countless resources and where developers of any applications or tools can easily provide access to any LLM to make use of their capabilities. So I really hope this protocol gets adopted widely and we see a very rich ecosystem, which is already starting to blossom in its very early steps. That's it for today. So thank you for tuning in. Happy building and see you around next time. Take care.